Okay, so now we got all our quadrilateral properties for parallelogram, rectangle, rhombus, and square. We should know them by now. This lesson, this front of this page here is a nice reference sheet. It kind of summarizes everything for you. Notice the yellow are true. What I have in yellow, it's a little shaded on yours. All yellow things here that you see on your screen, those are true for all four of them, because remember, rectangle, rhombus, and square, they are all parallelograms. They are all parallelograms. So they have all the properties. So a rectangle has all the properties of a parallelogram. The rhombus and square have all the properties of a parallelogram. There's the properties of a parallelogram, and these have the same ones. Now, a rectangle has all the properties of a parallelogram plus, boom, plus this. Okay? A rhombus has all the properties of a parallelogram plus this. Okay? But a rectangle does not have these properties. A rhombus has these properties but does not have the properties of a rectangle. A square is perfect because a square has every single property. Every property a square has. 4 right angles, congruent diagonals, 4 congruent sides, perpendicular diagonals, diagonals bisect angles. It has all the properties of a rhombus and a rectangle. Okay, so here's a diagram I want you to kind of keep in your head. You have a parallelogram. Oops. Let me draw that. You have a parallelogram. Okay. Parallelogram can either be a rectangle or a rhombus. Okay, so this is a parallelogram, and that can either be a rectangle or a rhombus. All right. Parallelogram can either be a rectangle or a rhombus. If it's got the 4 right angles and the congruent diagonals, it's a rectangle. It's a rectangle. If it's got the 4 congruent sides, it's a rhombus. One or the other. If it's got both, all the red and the blue, see the red and the blue? If it's got both, that makes it a square. If it's got both, that makes it a square. Does everyone understand this diagram? I hope you do. Okay, so and that's a square. All right, so you got a parallelogram. It could be a rectangle or a rhombus, and then if it has both, then it's a square. All right, so keep that in mind, because they might ask you questions like, which of the following is true? A rectangle is a square, or a square is a rectangle? Okay, so is it true that a rectangle is a square or a square is a rectangle? Well, a square is a rectangle. A rectangle is not a square. A rectangle could be a square, but it's not necessarily a square. Okay, a square is a type of a rectangle. Okay, a rectangle is a parallelogram. A parallelogram doesn't have to be a rectangle. A parallelogram could be a rhombus instead. A parallelogram could be neither one. Okay, but a rectangle, all rectangles are parallelograms. All squares are rectangles. So you got to kind of think of it like that. You are what's above you in this diagram. You are what's above you in this diagram. You are not necessarily what's below you in the diagram. And that's what we're going to have to get used to. All right, so we're going to use these properties now. Given the rectangle FGHI, how does the student know that the diagonal length is 13 centimeters? Well, if you have a rectangle, that means you have a right angle, right? You have a right angle here. So if you have a right angle, you can use the Pythagorean Theorem. All right, so we can use the Pythagorean Theorem to find the length of the diagonal. 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. 169 equals c squared. If you take the square root of 169, you get 13. And that shows that the diagonal length is 13. So you can do the diagonal of rectangles, and as long as you have the right angle, you can use the Pythagorean Theorem. given rhombus KLMN, a student claims that he could find all the angle measures in the rhombus just given one single angle measure, that x is 25. I'm just going to redraw this because it's kind of hard to see. It's like kind of squished a little bit. So I'm just going to redraw this rhombus, make it a little bit bigger. Try to explain. Oh, I kind of went off the diagram there. That's not good. Let me drag this back over here. Okay. Went off the grid there. All right. So basically what they're saying is, so we know this is 25. We should be able to find every single angle in this diagram, and that is true. You know why? Well, if this is 25, this must be 25 because it's a rhombus. Only because it's a rhombus. In a rhombus, the diagonal cuts the angles in half. It bisects the angles. So if that's 25, that's 25. Also in a rhombus, the diagonals where they cross in the X, right in the middle there, right here, they are perpendicular. That means they form right angles. So I have all four 90-degree angles right there. So that's 90, 90, 90, 90. Each individual triangle has to add up to 180. Boom, boom, boom. 90 and 25. 90 and 25 is 115. Okay? 90 and 25 is 115. And of course, these three angles got to add up to 180. So 180 minus 115 is 65. So I know this angle is 65, right? So now I have 25 and 65. I know this is 65 because, again, the diagonals bisect the angles. Okay, this must be 25, 25 for the same reasoning, right? Three angles triangle add up to 180. Okay, 25, 25. This must be 65, 65. So I am able to find every single angle. If I know just one angle, I'm able to find all the rest. And you would just have to put that in your own words if you had to explain it. Given square PQRS, find the value of x and y. Okay, so again, here's the thing. I know it's a square, right? So I know all sides are equal. So I know y must also be 3 radical 2. So y is 3 radical 2 just because all sides of the square are congruent. All right, so now, so to get this out of the way here, now I'm going to find my diagonal, which again is the hypotenuse. This is a right angle, so I'm going to do the Pythagorean Theorem. 3 radical 2 squared plus 3 radical 2 squared equals c squared. That's a squared plus b squared equals c squared. This is 9 radical 4 plus 9 radical 4. Now, radical 4 is 2, so this is 9 times 2 plus 9 times 2. So that's going to be 36. Okay, 18 plus 18 is 36, and then take the square root. C equals 6. So my diagonal is 6. 2 more. Find the measure of each angle in square PQRS. Again, a square is a rhombus. A square is a rhombus. So the diagonals are perpendicular. So I know all those are 90. And I know all 4 sides are equal. So I know that I have isosceles triangles here. That means each of those triangles has to be 45, 45, 90. It's got all these angles are equal. It's 90 cut in half, right? 90, 90, 45, 45, 45, 45, 45, all the way around. They're all 45. 45, 45, 45, all 45, okay? Given square PQRS, determine the length of one side of the square. All right, so now this one's tricky. Now they're giving us the diagonal, and you got to find the sides. I don't know any of the sides, right? However, I do know all the sides are equal. So I know it's x. I can call them x. I can call them x, and I can do the Pythagorean theorem like that. So it's a squared plus b squared equals c squared. A and b are both x. So it's x squared plus x squared equals c squared. C is 6 radical 2. 6 radical 2 squared. Okay? X squared plus x squared is 2x squared. And then 6 radical 2 squared is 36 radical 4. Radical 4 is 2. 36 times 2 is 72. Divide by 2. 2x squared equals 72. I already divided by 2. X squared equals 36. And then I take the square root. And again, x equals 6. So my each side must be 6. Okay? Each side must be 6 for this square. Okay, we'll see you in class tomorrow. We're going to do some proofs with quadrilaterals, use the properties as well. And we're going to do some more of these. So I'll see you then.